Hello friends, today we are going to start with mole concept and stoichiometry. Today we are going to see basic concepts of Gay-Lussac's law. So let's begin. So let's first understand the states of matter, because Gay-Lussac's law is applicable only for the gases. So we need to understand a couple of characteristics of gases, and the mole concept entirely is dependent on gases and gases only. So let's see what are gases. So gases do not have definite shape and volume. They have negligible forces of attraction between the molecules, and they are not rigid, and they can exert pressure throughout the walls of the container, and they have very low density and they have high miscibility. Here miscibility means the capability of that particular gas to move around and get homogeneously mixed with other gas. Solids, on the other hand, they have definite shape and volume. They have maximum force of attraction between the particles, and they are highly rigid. They can exert pressure partially downward only. They have high densities and they are not miscible. They are not readily miscible. So one might ask, what's then alloy? So alloys are basically formed when the solids are melted. That is, they are in the liquid state. And let's see what liquids are. So liquids have definite volume, but they do not have definite shape. They have less forces of attraction between the particles than the solids have. They are less rigid as compared to solid again, and they exert pressure partially downwards only, and the densities are less than that of the solids. And liquids are slightly miscible as compared to the solids, but quite less miscible as compared to the gases. So let's see what gas laws state. Set of rules which a gas follows when subjected to the change of temperature, pressure or volume. There are basically only three parameters that are important right now, which will subject change in temperature, pressure or volumes. The effect of change of any one parameter affects the other two parameters. First of all, then let's understand what temperature, pressure and volume means to us. So temperature is an indicator of the kinetic energy possessed by a molecule, and we have already studied this in the lower classes. It is measured in degrees Celsius and in Kelvin. Kelvin is generally used in this chapter of mole concept. So what is Kelvin? 0 degrees Celsius is equal to 273.5 Kelvin. To round it off, we can write it as 273 Kelvin as written in the slide. Pressure is the average force exerted by gas molecules on the walls per unit area. That is, the force per unit area is pressure, and it is measured in this chapter in terms of atmospheres. So 1 atmosphere equals to 760 mm of Hg, that is mercury, or 76 centimeter of mercury. Volume is basically the space occupied by a fixed mass of gas, that is measured in liters or cc, or in case of this chapter, decimeter cube is also used, which means the same as the liter. 1 decimeter cube is equals to 1 liter, which is equals to 1000 cc, that is 1000 ml. So we have already studied Boyle's law and Charles' law. So let's go through it. What does Boyle's law say? That is, given mass of a dry gas, dry gas here means without moisture, is inversely proportional to its pressure. It is inversely proportional to its pressure, and it can be mathematically represented as V is inversely proportional to 1 by P, where V means the volume and P means the pressure, where P is equals to constant, that is the temperature is constant. And when we take it into conditions, we can obviously write that P1 V1 equals to P2 V2. Charles' law. Charles' law states, when the pressure remains constant, the volume of a given gas, that is a dry gas, is directly proportional to its absolute, that is absolute temperature means the temperature in Kelvin. So when V is directly proportional to T when T equals to constant, and this can be written mathematically as V1 by T1 equals to V2 by T2. And combining both these laws, that is Boyle's law and Charles' law, we can give a gas equation, that is PV by T equals to constant, which can again be written as P1 V1 by T1 equals to P2 V2 by T2, which is equals to again K, that is a constant. STP, that is standard temperature and pressure. You need to understand this concept very thoroughly before we can move forward in this chapter of mole concept. So standard temperature and pressure means the volume of a gas are converted to standard temperature and pressure conditions and then compared. Just imagine you comparing the volume of a particular gas at 500 degrees Celsius will be more as compared to the volume of the same gas at 300 degrees Celsius. So to compare these two quantities, there is a standard, and the standard states that the standard temperature should be 0 degrees Celsius, that is 273 Kelvin, and standard pressure should be 1 atmosphere, that is 760 mm of Hg and 76 centimeter of Hg. And we bring all the given volumes of the particular gas to STP before we compare or solve any kind of numerical in this chapter. So please memorize these values. So let's start what we have started this video for, that is Gay-Lussac's law, which is also called law of combining of gases. Let's see what it states. When gases react, they do so in volumes which bear a simple whole number ratio to one another and to the volumes of the product. If gaseous, provided the temperature and the pressure of the reacting gases and their products remaining constant. Means the volumes of the reactants and the products, if the reactants as well as the products are in the gaseous state, will always be in a simple whole number ratio when the conditions of temperature and pressure remain constant. But in case of solid and liquids, we straight away write 0 and do not bother to assign any ratios to it, as the law doesn't work for solids and liquids. So let's see an example. Oxygen, that is O2 plus 2H2 gives 2H2O, that is steam, again a gas. And we already know that oxygen and hydrogen are gases at room temperature. And if you have observed, it is a balanced equation. So one more important point here, that Gay-Lussac's law should only be applied to balanced equation. So now, according to the Gay-Lussac's law, one volume of oxygen will combine with two volumes, give 2 volumes of water. So the simple whole number ratio here would be 1:2:2. Again, let's see another example, that is nitrogen plus hydrogen will give ammonia, 1 volume of ammonia. So the ratio becomes 1:3:2. Let's see an example, a very simple example here. A pharma industry manufactures a medical drug comprising of nitrogen oxide used as an energy booster. Nitrogen oxide is produced by the reaction involving oxidation of ammonia. If 100 liters of ammonia is used, what will be the amount of nitric oxide produced? So here, according to the Gay-Lussac's law, we can straight away write 4:5:4:, nothing, because it's liquid. We cannot assign any ratio to this. So, and one more thing to observe is this is a balanced equation, and now this is given 100 liters. Nitric oxide, what we will get will be 100 liters only, because the ratio remains the same, hence the factor, and hence the result, the answer will be, that is nitric oxide would be 100 liters. I hope guys that you have understood the concept of Gay-Lussac's law. Now let's see couple of numericals on this in the next video. If you have liked this video, please don't forget to share it, subscribe it and like it. And in case you have any doubts, please comment in the comment section. And if you don't want to miss any updates from this channel, please press the bell icon. Thank you.